Hello, welcome. In this session, I'm going to be giving you an introduction to 3D scanning. We're going to take a look at what it is, how it works, and hopefully leave you with an understanding of what scanners and software are best for your requirements, whether that's scanning an object from a few centimeters to an entire building. So what is 3D scanning? So 3D scanning is the process of capturing data of a real-world object or its environment, and this typically consists of capturing its size, its shape, and sometimes its appearance. This data is then used to construct three-dimensional models. These can be used for various different applications, but are commonly used for reverse engineering or inspection purposes. So why would you use a 3D scanner? So 3D scanners essentially allow you to capture complex curvature or geometry that would otherwise be too difficult or too time-consuming to measure traditionally. Now, it's not to say a pair of verniers are completely obsolete. Often a combination of traditional measuring methods and 3D scanning give you that best result when reverse engineering a component. It's understanding when and where a 3D scanner can actually add benefit and speed up your process. Take a hole, for example. Measuring the size of a hole is relatively straightforward with a pair of verniers, but actually understanding where that hole is in relation to other parts of the geometry accurately is a lot more difficult with traditional measuring methods. There are a number of different types of 3D scanners and 3D scanning technologies. Each of these have their own advantages and disadvantages. A professional 3D scanning solution can range from around £5,000 up to well over £100,000. The cost is typically influenced by the type of technology that these scanners use, the accuracy, and the resolution. If you need metrology grade accuracy, 20-30 microns, then you're looking in the tens of thousands of pounds. If 0.1 of a mil or 100 micron accuracy is more than adequate for your application, then you can actually get some extremely good professional solutions for under £10,000. In this presentation, we're going to focus on two different types of scanners. One of these is a structured light or white light scanner, and the other is a laser imaging scanner. These are both used for very different applications, but we're going to focus on how these work and what you'd actually use these for. Peel 3D is one of the brands we're going to focus on in this presentation. The Peel 3D scanners are ideal for reverse engineering applications. They can scan objects from around 3 centimeters all the way up to 3 meters. This is merely a recommended range, and these scanners are capable of scanning above and below this range. These scanners are aimed at the entry-level professional 3D scanning market. Peel 3D is actually a subsidiary of Creaform, who are the market leaders within handheld scanning. Whilst Creaform scanners start at just over £25,000, the Peel 3D scanners start at just over £8,000. These scanners use a technology often referred to as structured light or white light scanning. On the next slide, we're just going to have a look in a bit more detail as to how this actually works. A structured light or white light scanner typically projects a light pattern consisting of a series of lines or a pattern that often resembles a QR code over the object's geometry. As this pattern becomes distorted, the scanner is then able to triangulate how far away those features on the object are based off the cameras and sensors on the scanner. I'm just going to explain a little more about the reverse engineering workflow. The first step to reverse engineering a component is to physically scan the object. This is quite a simple process. It's a case of pointing the scanner at the object, pulling a trigger, and just ensuring that the scanner is looking at the part that you want to be scanning and making sure that it's within the correct focal range so that it's actually picking up the data. Once you have physically scanned the object, that will generate what's called a mesh. This is essentially a 3D representation of your part that's made up of a series of tiny triangles. 3D scanners are line of sight, so you need to ensure that the scanner has seen and captured all of the critical geometry of your part. Think of it a little bit like spray painting your part. You need to make sure that you've actually sprayed from all angles, ensuring that it's capturing that geometry. Once you're happy with your scan and you made sure that you captured all of the information you're going to need for reverse engineering it, you can then move on to a few other steps within the software. As a next step, you may want to align your scan in a sensible orientation so that when you import that into your CAD software, it corresponds with your front, your top and your right planes, which will help to aid the modelling process. In the software, there are various different features for actually cleaning up the mesh. So one of the first things you may want to do is actually remove any noise, typically caused by dust or reflection off the object, any unwanted data. There may also be a hole or two. You can either leave those or you can patch them up as you see fit. Once you've collected all the data you need and you've cleaned that scan up, there are two main workflows that you can choose to use. One of these workflows is a scan to CAD workflow. Essentially what you're doing is you're using your scan data that you've collected, helping to aid actually remodeling as a parametric model back into your CAD software. There are various different tools within the software that help with this process. Some particularly useful ones are to be able to best fit any entities such as a plane or a cylinder to holes, take cross sections. All of this information can be exported and brought into your CAD system that you can actually work from as you're remodeling the part. The other method is a scan to print method. You may spend a little more time in the scanning software actually cleaning up and making sure that you've got a watertight model before you actually transfer that straight to a 3D printer. This workflow is more commonly used where you're scanning an object that's very organic in shape and wouldn't really benefit from remodeling in your CAD software to create any parametric based features. Both of these workflows are completely valid and entirely depend on the application that you're actually using this object for. One of the things that's important to be aware of is a scanner's field of view. Essentially what this is how much the scanner is actually able to see per scan. So there's actually two models of the Peel 3D scanners. So there's a Peel to CAD-S model and there's a Peel to CAD model. As you can see from the images on the right, the Peel to CAD-S in the top image has a much smaller field of view compared with the Peel to CAD scanner on the bottom. This makes the Peel to CAD much more suitable if you're scanning larger objects, and the Peel to CAD-S if you're scanning smaller objects. Another important feature to be aware of with 3D scanning is the resolution that the scanner can capture. If we compare these two images, you can see that one has been scanned with a 0.5 of a mil resolution and the other has been scanned with a 0.1 of a mil resolution. Now it's important not to confuse resolution with accuracy. So resolution is how small a detail that the scanner can actually capture, and the biggest kind of telltale difference between these two is the text on this part. So you can see that with the 0.5 of a mil resolution, we're not actually picking up any text detail, whereas at the 0.1 of a mil resolution, we're picking up much finer detail on the scanner. So the smallest resolution that the Peel to CAD is able to capture is 0.5 of a mil resolution, and the smallest that the Peel to CAD-S is able to capture is 0.1 of a mil resolution. Now if you remember, they've got different field of views. So one is aimed at scanning smaller objects with a much finer resolution, whilst the other one's aimed at scanning much larger objects and has a larger field of view. Whilst the scan on the right may visually look better as it's capturing more detail, if I was using a scan to CAD workflow, I probably still captured enough information to reverse engineer that object at 0.5 of a mil. If I was doing a scan to print workflow, however, then the 0.1 of a mil scan is much more preferable because of the amount of extra detail that is captured. It's important to select the right scanner for the job. If I was going to be scanning an entire car, it'd be a lot quicker to scan with a Peel to CAD because it's got a much larger field of view. If I'm just mainly going to be scanning smaller objects, then the detail I can pick up with a Peel to CAD-S makes it much more suitable. These next couple of slides are just to show a few examples of the kind of objects they're able to scan with these handheld scanners. You can see these can range from small Christmas ornaments all the way up to large inside of van scans. You can see the white light scanners are actually able to capture texture. You can see the texture that is mapped over the hand scan in the bottom right hand corner. And you can see that these parts range from large kind of body panels of cars down to really small little calipers and detailed objects. Again, you can see an array of different objects that you're able to capture, from really mechanical objects, entire cars, down to really organic shaped body parts such as an ear. The last thing I'm going to show you is just us physically scanning an object so you can see what's actually involved in that process. So the next brand of scanner we're going to focus on is the Leica BLK360 scanner. So why would you use a Leica as opposed to the Peel 3D scanners? Leica is designed to scan much larger objects, such as room layouts, plant facilities, or entire buildings. As you can imagine, scanning an entire building with a handheld scanner would not be practical and would be extremely time consuming. So the Leica uses a slightly different technology to the Peel 3D scanners, and this is commonly referred to as time of flight. So the Leica actually uses a slightly different technology to the Peel 3D scanners, and this technology is commonly referred to as time of flight. So unlike the Peel scanners, the Leica actually stays in a static position rather than moving about the object. So the Leica is actually positioned in various different locations of the environment that you're wanting to capture. The scanner then emits millions of laser beams as it rotates in 360 degrees. As it does this, it's recording how long it takes for the light to reflect off the object and is able to work out the distance of the object from the scanner based off the speed of light. Unlike the Peel 3D scanners that capture a mesh, the environment is built up with millions of points, which is referred to as point cloud data. Due to the nature of the scanner often having to be taken off site, it's designed to be small, compact, lightweight and easy to operate. It just has a single button which both turns the scan on and turns the scanner on and off. This scanner is then just mounted on a tripod and just needs to be moved in various different locations within the building facility that you're wanting to capture. One nice feature of the Leica is the IR sensor, which allows you to capture thermal imaging of the environment you're scanning. The Leica has a range of about 60 meters and can be used both indoors and outdoors. Next, I'm just going to show you a recent scan that we did as part of a project with the 50,001 Youth Training Trust charity in Lowestoft. The aim of the project is to do a full restoration of an old RLLI lifeboat. And the video just shows a walkthrough of the kind of data which you can capture with a Leica scanner.